Okay. Okay. Another problem as far as solving what we call finding exact values. Okay. Notice I've got, I'm looking at a different type of equation now. I've got sine of inverse cosine 1/2 plus inverse sine of 3/5. Remember, what are inverse trig functions represent angles. So basically, what I have here is sine of a plus b. Okay, if we want to solve sine of a plus b, this is our formula, right? We're going to do sine of a plus b equals sine a cosine b plus cosine a sine b. So I really don't even need to solve for the angle so much as solve for, make sure I have all the, like I have here, all the cosines and sines, which I'm eventually going to get, okay? So here's that formula. So let's go about looking at first angle A. Angle A is, this represents an angle right here. Cosine inverse of 1/2, that's an angle, okay? Where cosine of an angle gives you 1/2, inverse cosine of 1/2 gives me an angle. You should know this, please know this, after all this time, that 1/2 is cosine of a 60-degree reference angle, okay? What goes with 1/2 for cosine or sine? The other thing is always √3/2, okay? So I don't even have to do, you could make a right triangle and have the hypotenuse be 2 and this be 1 and do the Pythagorean theorem. But you should know by now that this is a gimme, okay? Cosine's 1/2, sine's √3/2, that's 60 degrees, okay? So I really don't need to know the angle as long as I know cosine and sine. I didn't have to build the triangle, right? Hypotenuse is 2, adjacent's 1. This would be √3. 2 squared minus 1 squared, square rooted, is 4 minus 1. This would be 2 squared minus 1 squared is 4 minus 1, which is √3. So √3/2 is your sine, okay? But we knew that. All right, so we know our cosine and sine for that angle. Notice if I did this right triangle with the 2 and 1, hypotenuse 1/2 is my 1/2 is the cosine, adjacent over hypotenuse. I didn't even need to know 60 degrees, okay? But anyway, we did. So we've got sine and cosine now for A. Now we just need to find it for B, okay? So going back to the original, B comes from inverse trig function, okay? Inverse sine of 3/5. All right, so that's something I don't recognize from the unit circle. So we're going to have to do that little triangle bit. Here's my angle theta. Oh, and by the way, let me just go back. What was given in the problem also was this. Angle A is between 0 and pi. Less than or equal to pi and greater than or equal to 0. Okay? So cosine is positive. So it has to be in this angle. Cosine, this is from 0 to pi, and this is the only angle where cosine's positive. So here would be that triangle with 2 and 1, okay? We find out that's √3, okay? All right, sine is √3/2. All right. Now in this angle here, my thing's kind of slouching over here, okay? Oh, I'm having technical difficulties here, guys. Hold on. Okay, my thing keeps holding over. I'll have to use left-handed here. All right, so where was I? I've got, I know angle B is this angle, inverse sine of 3/5, and it's given to me that B is less than pi halves, less than or equal to pi halves, and greater than or equal to negative pi halves. That's from here to here, okay? That's less than or equal to pi halves, but greater than or equal to negative pi halves. But where's sine positive? It's only right here. So again, quadrant 1 is where we build our triangle. 3/5 is sine. Opposite over hypotenuse. Okay? All right, when you solve for a leg, I'm not going to lead you through 4 years of Pythagorean theorem. It's 5 squared minus 3 squared. Hypotenuse squared minus leg squared. Square rooted gets me 4. So now I know this triangle is a 3, 4, 5 Pythagorean triple triangle. My cosine is 4 over 5, adjacent over hypotenuse. So we had two angles, and if we're going to do this formula right here, I needed to know sine and cosine of both angles, and we know them all now. So I can add this up, okay? So here's cosine A is 1/2, sine A is root 3 over 2, cosine B was 4 over 5, which we just figured out, and sine of B is 3 over 5. So now I can plug in root 3 over 2 times 4/2 is 4 root 3 over 10. Cosine A 1/2 times sine of B is 3/5, so 1 times 3 over 2 times 5 is 3/10. Okay, so I've got 4 root 3 plus 3 over 10. Okay, so that's how we solve this problem here. Looking back, what was key is that, okay, and don't let these inverses fool you, that represents angles. Okay, this is basically sine of an angle plus sine of an angle plus an angle, which is sine of angle plus b. We know our formula. Just go about whether you know that represents something off the unit circle, or here build your triangle based on where your triangle could be. For angle B, we exist in 1 and 4, but sine's only positive in 1, so that narrows it down. An angle, this one here, for cosine, we knew it was 60, but we also were given that restriction that it was angle A was between 0 and pi. Cosine's only positive here, so again, quadrant 1. Pretty easy stuff, guys. I'll have a problem like that tomorrow to work on, okay? And we're going to finish up just some practice on what we've done and have a test probably Tuesday, all right? All right, you're all responsible for this, and I'll post the worksheet on my website for everyone to practice this type of practice. The rest of the stuff we're going to have is going to be review, okay, over all our trig things. Let's see. Right here. The cosine, okay, the sine, and we did tangent, okay, and then now we're just doing some extra work on that. So we'll probably have, be prepared for a test Tuesday, okay? We'll be moving on to some new things. All right, have a good night.